Welcome everyone. Thanks for joining us today. I think more folks will join as we get started, but I don't want to delay any further. So I want to welcome Bailene, who is very generously volunteered to take this webinar session today. So Bailene is from the University of Nairobi, and she's currently a data scientist with a unique interdisciplinary background combining data science, health research, and financial analytics. She holds a Master's of Science in Data Science from the University of Nairobi, where she was part of the pioneering cohort under the APRIA-DSP initiative. The research interests focus on leveraging machine learning and data analytics to address public health challenges, particularly respiratory diseases and environmental health. She is passionate about demystifying data for decision making, helping researchers and professionals uncover insights from raw data using accessible tools. So thanks, Celine, for joining today and giving us some tips and tricks that you've come up with some analysis in our. So over to you. Thanks.
Thank you so much, Yolanda. I'm so much honored today to present on exploratory data analysis, particularly on focusing on how it helps us unveil hidden patterns in data. Welcome everyone once again. As early career researchers in data science, I believe this is one area that we probably interact with often. And for some of us, or many of us, it's a daily part of our workflow. So this presentation is actually designed to feel more like conversational. So feel free to ask questions as we continue. Thank you. Now, just to lay a background, what is exploratory data analysis? EDA is a critical step in the data science workflow that majorly involves examining and summarizing the main characteristics of a dataset before applying the more complex modeling or statistical techniques. And it mainly helps us in summarizing the data through the descriptive statistics, identify missing values, outliers, and anomalies. Also, maybe the process of data quality checks. And also through the data visualization, we can be able to discover patterns and trends in your data set. And finally, pinpoint variables of interest to help us in modeling. So EDA is basically the foundation. When EDA is thorough, our analysis and modeling will be much more reliable for decision making. The objective of this presentation actually was to explore patterns and trends in health outcomes linked to PM 2.5 exposure. PM 2.5 is an air pollutant that is associated mainly with respiratory and cardiovascular diseases. So the focus area was Nairobi County, particularly because it's considered a pollution hotspot due to urban activity in Kenya. And then our data set includes patient visit records, both outpatient and inpatient from 2021 to 2023, with a specific focus on respiratory and cardiovascular diagnosis. I sourced these data sets from the Global Environmental and Occupational Health Hub, which is situated here at the University of Nairobi. It's a research center, actually. That sources it collects data from various hospitals within Nairobi County, and it also has the air equipment that collects the PM 2.5 exposure. So that's why I collected the data set. Just to get to the summary of the data set that I used, before actually we get into this, I shared a health data set that I picked randomly from Kaggle. I want to believe that some of us or all of us got a chance to check it out. if you manage to check it out, you'll notice that it's actually comprehensive as far as the variables are concerned. But for my dataset, it had 203, 602 patient visits or records total. And the key variables were the appointment date, sex, age, diagnosis, ICD-10 code, and the residence. Now, the appointment date ranged from March 2021 to December 2023. And the sex, we see there's a male and female. For the missing data on the sex variable, they were explicitly labeled as unknown just before importing into R. Then age ranged from 0 to a maximum of 120 years. So just simply from this summary statistics, we can notice that there's a presence of outliers. I mean, 120 is extremely larger than these other data points. And then diagnosis, the most common diagnosis was respiratory disease. We'll discuss maybe further as we go on. And then the ICD-10 code was J0. Nairobi. I actually had an issue with the residents because you see the data set was labeled Nairobi County. I'd prefer maybe using Nairobi County is large, so maybe they would have broken down it into constituencies or sub-constituencies, maybe for more informational decision making, but that's what we had for today. Then now for missing data analysis, on the appointment date, we had 2,141 missing data points. And then the sex, remember the missing data was labeled unknown, so it had 0 missing point. And then age, diagnosis, ICD-10 code, and residence had 729 missing data. Now I've checked the 729 missing values and just maybe to confirm if they occur in similar rows. Perhaps I would have considered to delete the empty rows, but then they did not occur in the same row. Some rows had missing ages, but not diagnoses. Some had missing ICD-10 codes, but had residence and so on. So this prompted me to you impute, for example, in the median, the appointment date, I imputed the median dates using the median dates because median is less sensitive to outliers as compared to mean. And then age being a continuous and it was right skewed variable, median imputation was preferred over mean. For missing diagnosis, ICD-10 code and residence, okay, for missing diagnosis and ICD-10 code, I labeled them unknown just to allow inclusion in frequency plots and to preserve the data set structure for exploratory data analysis. And then for residents, since all of them were labeled Nairobi County, I just labeled them Nairobi because of the geographical context of data collection. Now, on the univariate analysis, this is the another step in the exploratory data analysis. You can see this is the box plot that shows the distribution of age of the patients. And from this box plot, you can see it is right skewed. It shows a right skewed distribution, hinting at a bulk of young patients and few much older ones. The outliers detected above 100 years, can see ages up to 120 suggest few elderly patients or possibly data entry errors. So minimum was 0, then the median is about 25 years old. First quartile you can see it's 3, then the third quartile is about 42 years old, then the maximum is 120 years. Now, on the gender frequency, you notice that women make up the larger proportion of patients, and can also see that there are very few entries that have unknown gender variables. The many female or the many women probably could reflect the healthcare seeking behavior or demographic reality, or perhaps a higher susceptibility or concern among the women. So the data quality is good. We can say it's good because there are very few entries having missing or unknown gender values. And since gender distribution is nearly balanced, analysis stratified by sex can be done without concern for severe imbalance. Okay. Now, on the top diagnosis, you can see that respiratory disease was the most common in this data set. Maybe because indicating a higher burden for better documentation of respiratory disease or conditions. But this imbalance could influence modeling, especially if used for classification, like in my case, the random forest modeling. So appropriate techniques, statistical techniques like oversampling or random undersampling might be necessary for modeling purposes. So essentially, this is the main advantage of exploratory data analysis. It gives you the key summary or the key characteristics of your data before you proceed to model. On the age distribution, this is now the bivariate analysis, age distribution by diagnosis. You can see the respiratory cases are predominantly in younger individuals, as we noticed in the first case. Now, while cardiovascular cases are more common in the elderly, which is usually maybe the case. The cardiovascular diseases are usually common among the elderly as compared to the respiratory diseases. And then the age spread for cardiovascular patients is more balanced across the spectrum as compared to the respiratory disease. You see, the respiratory disease shows more extreme outliers, mostly on the elderly or the older patients. Gender-wise, the female patients outnumber males in both cardiovascular and respiratory diagnosis. And respiratory diseases occur far more frequently overall, as depicted from the visualization on your screen. And interestingly, entries marked with unspecified sex are minimal and could be ignored for modeling. As you noticed in the gender, they're quite minimal. Now, on the temporal trend, you can see respiratory cases marked with green and cardiovascular cases marked with red. Cardiovascular respiratory cases peak around May and July from the trend, and cardiovascular cases are relatively stable. So this can help maybe in planning by the healthcares personnel, maybe for planning, because can see May and July, respiratory cases are peak, for cardiovascular cases are relatively stable. Seasonality may correspond with pollution, however, and weather patterns. Maybe for respiratory diseases now, in my case now that I was associating them with PM 2.5 pollution, maybe we could investigate further. Maybe it's pollution levels or the weather patterns influencing the peak on the respiratory cases. Then the unknown diagnoses are minimal and almost flat throughout. Now, from the analysis that I did, the key insights we have picked were seasonal trends in respiratory illnesses, likely weather or pollution related. And then age and gender distribution showed burden among youth, especially females. And then the missing ICD-10 codes would affect reporting and analysis because we cannot tell exactly which disease is common or which disease is predominant. Okay, so these insights help lay the groundwork for robust modeling and targeted interventions. For my next steps is to predict. I actually predicted, I modeled using random forest, but now I'm continuously including other machine learning algorithms to compare with the random forest. And then to investigate pollution, health linkage more rigorously, especially to include more variables possibly, such as maybe the smoking status, their local, instead of Nairobi County General, just to make sure that maybe engage stakeholders in data improvement efforts to include the sub-constituencies or where they locally stay to have more informed data for decision making. So thank you, Rolanda. Maybe it's now open for discussion, comments, questions, concerns. Yeah.
So thanks, Berlin. Berlin, are you going to step us through some R code, or is it just open for questions now?
Okay, I can take you through what I did on R.
There is a hand. Okay.
Sorry, can take you.
There is a hand for a question from Ijama. So let's just maybe take this question first.
Okay, fine.
Sure.
Hi, Valine. Thank you so much for this. I just have a couple of questions. The first one is around your PM2, where you got that data from, because I know like with air pollution, it's very sort of localized.
Yeah.
And so is it just a general average PM2 across Nairobi?
No, it's actually real-time data collected from the beta attenuated monitor that is situated around Nairobi campus, the low campus. So it's real-time data actually.
Yeah, so for example, if a participant is or a patient is living wherever they're living, like how close is that to where that data? I'm just talking because one of our things around these things is always about exposure misclassification. Like, how do you know that that is what they're actually being exposed to if it's only collected from one place or reported
Yeah,
from one place?
yeah. Thank you, Jim. That's a valid concern because they say air travels. Okay, they use the fact that air travels will be in larger kilometers, miles, so they tend to associate it with that. But also in the locals where they collect data, there are also local monitors, local sensors. I think they're called local sensors, where they also use and then they compare with the attenuated monitor now for validation. But still,
Right.
your concern is very valid.
Yeah, so on an individual level, on a local level, maybe, but on an individual level, it might be a bit trickier
Yeah.
to be able to say that. The other thing I wanted to ask you about was around the graph where you were showing cardiovascular versus the chart, cardiovascular versus yeah, this one.
Mhm.
Sorry, I'm trying to look at it properly. So I see that it's really July, is it July 20, sort of May, July 2022,
Allô, oui.
Yeah.
where you have that peak, but in the other,
Oui, je suis là, Tanina. Bonjour tout le monde.
oh, sorry, hello?
Sorry about that.
Oh,
Just
okay.
muted.
No, I'm just saying, like, I can see, like, is it May, July that you've got 2022, but in the other years, like, for example, in 2021, it wasn't. In July 2021, it seemed to be, like, not as much.
Mhm.
So I'm just wondering, like, how you would, like, if we're going to say July, if you're going to say, okay, July is the most dangerous month or whatever, the month that people need to be
Yeah.
careful of,
Mhm.
is looking at, is that the case across the different years? I understand this is like just the years of the data that you have, but I'm just wondering your thoughts around that because it doesn't seem to be so clear cut to me.
Okay. Yeah. Okay, fine. Thanks. It's true. It only appears in 2022. It peaked in 2022 and maybe 20 July. So yeah, I think maybe, I don't know, is it maybe COVID or something? But yeah, I think it's what information, as you say.
Mm. I mean, it
Yeah.
might be worth sort of seeing if there's a difference, I don't know, between all those different, as in from one year to the next, the months that you do have. So if you've got March 21, March 22, no, you don't have March 20, do you have March
Oh,
23?
2022. Yeah.
So like, you know what I'm saying? Like comparing those months to see if there's like major differences around that. You know what I'm saying? Like seeing if it's definitely in July, even though, if definitely, whichever month it is, tends to be the
Mhm.
month that you're actually having these peaks, as opposed to just some outlier somewhere that just happened in that particular year.
Sure. I'll have to check it out again.
Mm,
Yeah.
yeah.
Thanks for that.
Thank you.
You're most welcome.
There's another question in the chat. I don't know if from Francesca, she's asking if you're applying any special strategy to the unknown gender column or if you ignored them.
Sorry, I didn't get a question.
So Francesca is asking if you applied any special strategy to the unknown gender columns or if you ignored those. Unknown
What
gender.
annual
Sex. Unknown sex.
I don't know. It's not coming out clearly. Maybe I can see the question. Like I'm not.
So where you had unknown sex, I think. Yeah, unknown sex unknown. Wanted to
On
know
this
if you
slide?
what the strategy was. Strategy was.
Sorry, Rolanda. I'm not getting the exact question. I don't know why.
Francesca, if you want to maybe explain.
Yeah, please.
Francesca, you're able to speak. We'll get back to that one then.
I'm guessing the question is probably around how you just handled that, you know,
Oh,
missingness in the data with gender.
okay. Okay, fine. Now get it. Do you apply any special strategy to the non-gender columns? Not really. I didn't apply any special strategy. I just labeled them for visualization purposes. I just label them unknown. Or maybe do you have some special strategy I can apply going forward?
Not sure if Francesca is able to hear us. But we can maybe get back to if Francesca is able to speak later. But I think Lemmy, you might have had a question. Do you want to go ahead? Lemmy is not on the call anymore. All right. Oh, yes. So, Beline, I was asking if you had any R code maybe to show associated to the analysis.
I did it here. Explanatory data analysis. This one. So I began by.
Are you sharing your screen? That
Oh,
screen,
yes,
or the
yes,
new
yes.
screen? No problem.
Sure. Is it visible?
Yes.
Okay.
I see
Yeah.
Lemmy is back on the call. I don't know if Lemmy, you had a question.
Who? Someone has a
Lem-
question?
Lemmy, he had his, I think he was unmuted. I'm not sure. Let's ask it. Lemmy, did you have a question? Or maybe it was just joining and rejoining. Okay, now. Go ahead, Pauline.
Okay. So I began loading the required libraries, that is since I was importing the data set was in Excel. The library read Excel was important. DPYR, tidyverse, tidyr, pull anytime, data the table, and ggplot were required for my analysis. Then I proceeded to import the data, the patient data set. Then to read the Excel files, continue to do that. Find it funny explaining the R codes. Then now to the function to process files in batches and save each batch to the disk. Okay. Rolanda, help. It's okay.
No, that's fine. Then if there's questions about the code,
Sorry?
I'm not sure if there's any questions from the
Oh, okay.
participants. Yeah.
Okay, fine. This is simply just to import the dataset and to read the dataset into R.
Is this from the same data set that you shared on the advertisement?
Yeah, on the
Okay.
yeah, it's the one.
Okay. I don't know if there's anybody on the call who actually ran the analysis.
Okay, for purposes of this presentation, you see, I was importing this data set separately for completeness or to check the data qualities. So I began with the health data set first. Then now, okay, on this one, I didn't import the PM 2.5 data set.
Okay.
Otherwise, in the research project, I imported the PM 2.5. That's why we have in the slide deck, we don't have the PM 2.5 data set.
Okay. Okay. I don't know if there's any other questions about the analysis.
Maybe I don't know what's her name. about this strategy. Maybe she can share with us the strategy that she thinks they can apply on before labeling the unknowns on the gender.
That was from Francesca, but I'm not sure if Francesca is hearing us. She's not responding.
So now I want to now explore the structure of the data set. Let's see, there were an extra unnamed columns. Maybe we can check before there was.
There's a question from Ubong.
Okay, yeah. Good afternoon, everyone. Good afternoon.
Good afternoon.
Yeah, please, I would like you to help us with the stepwise approach you used to do the analysis for people like very new on the R analysis platform.
Sorry, would you please come again?
Okay, so I would like to see the steps that you use in analyzing your data on R. So some of us are very new to
Yeah.
the
Okay.
platform.
So that's what I'm actually doing on R. I first exported the dataset. Now on the exploration now. Okay, fine. Let us just see before I dropped the unnamed columns. Over. So you can see there were unnamed columns from Excel 7, 8, 9, 10, and so on and so forth. And that's why I proceeded now first to drop the extra unnamed columns. And then I convert the appointed date to date format only. And then there was the time aspect from the appointment date column. That is, what time did the patient step in, and so on and so forth. And then to ensure age is numeric and valid, this is what I did. These are the codes. Okay. Now, just to confirm if that is done, yeah, so we dropped the extra columns. So the output is a summary of a table, which is a modern version of a data frame in R that contains 2,003,602 variables, observation, and then by 6 variables. Okay. Now, on the descriptive statistics of the variables, you can do the summary using the summary function. Then this is the summary statistics. Now you can see it's from March 2021 to December 2023. And the NAs, which is the missing values, were 2,141. Okay. And then the age, okay, the sex, these are the string values. But summary function out displays the numerical values. Age ranges from 0 to 120 years. The median is about 25 years and the mean is 25.6 years. Missing values are 729. These are character or string values. Okay. This was to convert the column names to syntactically valid names. For example, the health data on the health data set. So this was just to make sure that the sex variable in the health data set there was male, female. Remember, the unknown was explicitly labeled on the Excel sheet that was collected from from GeoHealth. So this is the summary that I shared on the slide deck. You can see the residents, there are only 202, but from the dataset, we notice it has 203 variables or observations, sorry. So this is to calculate the standard. This is just by the way I was doing to calculate the standard deviation of the age, which is 22.45, which tells us, okay, the standard deviation tells us how much individual ages vary or spread out from the mean in the data set.
Okay.
Sorry?
I don't know what
Then-
that was. But I do see Victor has a hand up. I don't know if Victor had a question related to the output.
Someone has a question?
Victor has a
Yeah.
hand up.
Yeah, okay. Thank you very much.
Mm.
Thank you for your presentation. That was a good analysis presented. In my concern now, in line with what Ubon has said, since most of the applications in our has to do with command prompt, and for those who are new in our application, like us, without mastering the right commands to use at a particular time to import the coded data in the our file studio. So it will be very difficult to run the analysis. So yours in line to what he said. So maybe I will appreciate if we can have a kind of a command code step and introductory part, what code to use at what time, if you want to do this, the code and the prompt to use, when to use the tag, when to use the greater than underscored, like that, because I remember when you are doing some code in R, there's a time you are going to use, when you use the underscored prompt, when we're not supposed to use, you will not get it to show an invalid data. So all those minor steps. So I will appreciate, at least for beginners, to have such a guide to help them understand the package properly. Thank you.
Wow. So that's an introduction to R entirely. I thought actually we have interacted with R. I'm so sorry about that. On
So,
the hash.
So
Yes.
sorry, Valine, we do have, so when you share this presentation, and maybe it's like this article, because this is a publicly available data set, I can share the other video, because you are not the first person who presented on R. I think it was Daisy, who had also presented on this webinar series, running something in R. But when Daisy shared it, I still have the video and introductory handbook for R that she shared to familiarize yourself with the functions. So I think I can share that when we share your presentation slide deck, because then it might, and then if there's some questions on top of that, then I think you can respond appropriately. If that helps.
I think that will help a great deal
Yeah.
to help
Sure.
every other individual to master the application effectively. Thank you.
Sure.
I'm so sorry for assuming we all have interacted with R. I'm so sorry about that.
No apologies. It's fine, because that is what it's all about. Everybody is at different stages of we understand everybody's at different stages of their project. So we won't be able to get everybody on the same baseline unless we had like very many training tutorials. So don't worry about that. But we will definitely try and share some extra material for those other folks that need it.
Sure. Thanks, Rolanda, for that. Okay.
I think Francesca now has her hand up. Please go ahead.
Hello.
Hello.
Okay.
Thank you so much. I must apologize because I was in another meeting. That was why I couldn't respond the moment I was needed. But specifically, what I wanted to ask is, you see, after the acquisition of the data, there were some columns that the gender was empty. So
Yeah.
asking if you used some special strategy, for instance, in my country, you could decipher the gender of an individual by their names. So I don't know if maybe you used similar strategies to, you know, fix in the gender, or maybe you just ignored the columns.
Okay. Not really ignoring. I just labeled them unknown. So what do you do in
Just
your country?
unknown.
Yeah, I just labeled them unknown. I wonder what you do in your country. So you name them female, male, and then what else?
Yes, you
What
can
did
know
you
the
say?
gender of somebody by their names.
Yeah.
Maybe first name and then, yes, primarily their names. You could know their gender. So I was thinking maybe that could have been a strategy to,
Okay. By then, okay, no.
yeah.
Actually, the names there was no name in the data set. They were
Okay,
just
okay. The names were
they
removed
were not
before
shared. They
you.
were,
Okay.
yeah.
All right. Okay. So there
The
was
data
no
set
way
just
for you
gave
to know.
us the identity numbers, so there was no
Okay.
name. Yeah,
All
disclosed.
right. All right. That's fine. Thank you.
Thank you. Okay. So now I'm so guilty going on, God, but it's fine. Now I can continue to do the modes and the age modes of the the most common age group that was affected, and it suggested infants, 0 represented infants from the data set, which is a critical insight, especially for public health uh, and respiratory illness studies. Now, to standardize the sex values, this is the code that I used. Now, to check the sex column, remember we couldn't see it in the summary statistics. Now, use the table function, and then can see about 52% represents the female, 26% the male, and 0.3% the unknown patients. And then now this is just for cleaning the white space to help me proceed with the analysis. To check the residence column, this is again 729 missing. The diagnosis column, you can see about 23% cardiovascular and 77% respiratory disease, and then there were 729 missing. Now this is to check the entire columns that are missing data. The one that I shared on the slide deck. Oopsie, sorry. Correct column names. Print is missing summary. Okay. This is what I shared on that slide deck. Then the ggplot for visualization now. Oopsie. Just ignore, but it's the missing data. It was trying to visualize the missing data points, but it's now to handle the missing data, imputed the median appointment dates. The missing is the median. then imputed age also with the median, then labeled diagnosis. There was some missing diagnosis, so just label them for unknown for exploratory data analysis. Send to ICD-10 code, send to residents. Then I confirm the changes. Yeah, so there are 0 missing data points. Okay, just to view the ICD-10 code. Okay, view top 10 ICD-10 codes. So the J's represent the respiratory diseases. Okay. And the invariant analysis on the patient's age, convert it, and then I can remove the extremes, that is 120 years. Then I do the exploit. So this is the box plot initially. And then this is just to calculate the quote there up on the third quartile, define bounds, and find outliers, and then summary. There were 9 outliers so far, the box plots. Can see from this, 49 outliers. Still the box plot, but just shaded blue. And then the patient said replace invalid or missing entries with unknown. Then now I can plot the box plots. As I generated the plot now. Can see the slightly higher number of females than males, as you have discussed from the slide deck. Then the diagnosis is here. Then I plot more respiratory diseases than cardiovascular. Actually, the data set was imbalanced. Yeah. Then on the bivariate analysis, can see this is to plot diagnosis versus the age. Cardiovascular is more common on the elderly than respiratory among the youth and the young. Unknown is minimal. Then we have diagnosis, to plot diagnosis versus sex. So this is it. It's more common, females are more affected than the males in both diseases. Then this is the trend analysis. Which I'm yet to check again. This may be invalid as we have noted. 2022, 2023. Yeah. So this was my analysis actually. Unless someone has a question, Rolanda.
Great. No, thanks. Thanks, Berlin, for stepping us through all the code. You'll be able to share this code because it is a public.
Sorry, I can share.
You will be able to share the code with me, and then I can share with the participants.
Yeah, sure, I can.
Sure. Well, that would be great. Don't know if there's any further questions for Berlin. I've also placed in the chat the other resource that we had, but I see, thank you so much to Mukri. Then we also shared a data camp resource of introductions to R. But I've saved this chat, so I'll also share that when I share the slide deck and the code with you guys for the presenters. Sorry, for the participants. Are there any other questions? If there's nothing, I'll close the session today. Thank you so much, Faylene, for giving us insights into your project and for showing us how you managed to do your analysis. And thank you also for the participants for asking questions and for coming to the webinar and for engaging actively with this resource. We're hoping to bring you more webinar series that demonstrates the tools and analysis. And hope to see, I've not scheduled a next webinar yet, but please be on the lookout for more to come. But thank you so much, everybody, for joining today. And with that, I'll close this session.
Thank you so much.
I will also share the recording, so don't worry about that.
Okay.
Yeah. All right. Thanks, everybody. Hope to see you next time.
Bye.
Thanks, Aline. Good day further.
All right, bye. Thank you.
Okay, bye.